Alright guys, today we are going to start our chapter on trig, but before we actually get into the Algebra 2 part of trig, we've got to do some geometry trig review. And we start out with 45, 45, 90 triangles, not 09, that's a typo on my part. 45, 45, 90 triangles. And this is not trig as you knew it in geometry, but in a few days you'll see how it relates to the trig we need in Algebra 2. So for a 45, 45, 90 triangle, a couple things you need to know. It has two congruent sides, which means it is actually an isosceles right triangle. So sometimes they won't show you that it's 45, 45, and 90, but they'll show you the 90 and the two congruent sides, and you're supposed to know that that is a 45, 45, 90 triangle. Also, you have two congruent acute angles. So here, the congruent angles are marked. They are each 45 degrees, and sometimes they will just mark those angles as congruent, and you are supposed to know that it's a 45, 45, 90. In a 45, 45, 90 triangle, the congruent sides are called legs, and the hypotenuse is always the longest side. Okay, that is true for every right triangle. Okay, but the way that the ratios for the sides of a 45, 45, 90 triangle work are the two congruent legs are both a, the hypotenuse is a times the square root of 2. So now we're going to see a couple of examples. So here for 45, 45, 90 triangles, if you look here at number 1, the side they have given me is the hypotenuse, which remember it is supposed to be a square root of 2. So you can look at that and you can see that a should be 5. So each of those congruent legs are 5. In problem 2, they have given me one of the legs of a 45, 45, 90. So I know that the other leg is 3. And then if you'll remember, your hypotenuse is equal to a square root of 2. Well, remember that a is just the leg. So if I substitute the word leg for a, and I have leg square root of 2, to get my hypotenuse, I'm going to do a leg times the square root of 2. So there's my hypotenuse. So now, for number 3, they've changed things here just a little bit. They've given me a hypotenuse, but it doesn't have a square root of 2 on it like it is supposed to. So that's where I'm going to use my formula. Okay, my leg times the square root of 2 is equal to the hypotenuse. So I don't know what the leg is, so I'm going to leave it there, but I know the hypotenuse is 10. I can solve this equation for the leg. All I'm going to do is divide both sides by the square root of 2. So at this point, I have the leg equals 10 divided by the square root of 2. But you can't leave your answer like this. Here's where we have to do something called rationalizing the denominator. You should have seen it in Algebra 1. We may have done just a little bit of it earlier in the year, not much, but it's real easy. Here's how it works. Because that is a square root on the bottom, I am just going to multiply by that square root over itself. Remember, if you multiply by something over itself, it's the same as multiplying by 1. And here's why I do that. When I multiply across the top, I get 10 square root of 2 On the bottom, I'm going to get the square root of 4, which is 2. And now my 10 over 2 will reduce to give me 5 square root of 2 for each of the legs. So here's your shortcut for that. Let me slide down here to the bottom of the page where I've got a little bit more room. When the hypotenuse is given, and it does not have a square root of 2, or it's just a number, without the square root of 2, here's my shortcut. I'm going to do the hypotenuse divided by 2 and attach a square root of 2 to it. That will equal the legs. So now let's go back and look at the one that we just did and see how that holds true. If I take my hypotenuse, divide it by 2, I get 5, stick a square root of 2 on it, and there you go. Let's see if we can do this for number 4. For number 4, my hypotenuse has a whole number on it. It does not have a square root of 2. So if I use my shortcut, I'm going to say 4 divided by 2 is 2. Attach a square root of 2. And that is the length of both of the legs. So now for number 5, they give me a leg, and it's got a square root of 2 on it. None of the others we did looked like that. So remember, you're just going to take the leg times the square root of 2 to get the hypotenuse. So if the leg is 7 square root of 2, and I multiply that by the square root of 2, then what I end up with is 7 square root of 4, which will be 7 times 2, gives me 14 for my hypotenuse. And then I know automatically that the other leg is 7 square root of 2. So here's my shortcut for that. When the leg has a square root of 2, we're going to ignore the square root of 2 and double the number in front to get the hypotenuse. Okay. All right, let me pause this just a second. All right, guys, we are back. So let me just sum this up again. When the leg has a square root of 2, you're going to ignore the square root of 2 and double the number in front to get the hypotenuse. All right, so let's look back at the problem we just did. Number 5, the leg is 7 square root of 2. So if I ignore the square root of 2 and double the 7, I get 14 for the leg. So now, number 6 here, they gave me the hypotenuse. The hypotenuse does not have a square root of 2 on it. So my shortcut is to take this number, divide it by 2, and attach a square root of 2 to it. Square root of 2. If you don't like the shortcuts, you can always go back and do it mathematically the way we did problem number 3. But with 45, 45, 90 triangles, I tend to use a formula once so that I can find a pattern, and then I just follow the patterns and do a little bit less work for those. So let me put up a practice page, and I'll give you just a couple minutes to work on it. You may need to pause it, and then I'll put my answers up, and you can check yours after you finish. Alright, so there's your 6 problems. Like I said, you may need to hit pause, because I'm going to go ahead and put my answers up. After you finish it, start the video again and check yours. Nope, that other leg is just 4. My hypotenuse is the one that's 4 square root of 2. There you go. Go ahead and check them, and then we're going to end this video, and I'll come right back with 30, 60, 90 triangles.